I thought I would share a short video on some of my favourite mill upgrades. These include a Quill DRO, some cable management, a table bib and an air manifold to provide an air distribution system. G'day, I'm Steve-O and welcome to the Outback Shed. Firstly, I want to install a digital readout on the Quill. I installed an iGaging digital readout on my Toolmaster load tailstock and I really like it. It's iGaging, it's made in the US and that makes it the best in class. The instructions are comprehensive and the exploded diagrams make it very easy to visualise the assembly. The backplate has a series of mounting locations to allow for different milling head sizes. A trial assembly sorts out which set of holes I need to use before the final install. The package comes with all the hardware needed, and I do mean all. It includes all the socket head cap screws, brackets and a battery. I'll locate the top mounting screw, then lower the quill to align the scale to the axis of the spindle. I don't have any black washers the correct size, so I'll have to use a paintbrush later. This quill has 155mm of travel, but the DRO maxes out at 140. It has millimetres, inches and fractions to 64ths. Not sure when I'll use fractions, but, well, you never know. My previous mill had a Heron Forms readout, but they're no longer available. However, I was able to purchase this iGaging Quill DRO. I'll leave a link to that in the description. The DRO fitted straight out of the box with no modifications or changes needed, not even to the quill bar. The whole installation took less than half an hour. Cable management always seems to be an opportunity for improvement. This mill has a very good cable management system, but there is an improvement just waiting to be had with the cable routing to the motor, power drawbar and safety switches. I drilled and tapped 3 6mm holes to mount a length of cable track along the side of the ram. This makes short work of containing these cables, and it looks good. Next up is a table bib. It's particularly useful when installing or removing heavy vices, rotary tables and dividers. It's made from 2mm sheet steel and it's slightly angled towards the table, which will provide some containment of coolant and stop it from running into the switchgear for the power feed limits. The front edge of the bib is between 1.5 and 2mm lower than the surface of the table, so as not to interfere with any items bolted to the table. And it's one of my favourite mill additions. It's great for any mill, big or small. To use the power drawbar, I need to plug the air supply into the regulator which is mounted in the back of the column. This works fine for the drawbar, but it doesn't provide any opportunities to use air for other reasons, such as an air gun, mist coolant or any other toolant that would require air. The requirements are for an inlet, a take-off to the power drawbar, 2 standard air outlets, a pressure gauge and an outlet through a small regulator to a later addition of a mist coolant system, plus an isolation valve. My idea looks something like this, and it's made from parts I already have. I'll make a small manifold from an offcut of aluminium that's 90 by 45. The bandsaw will make short work of it. All faces need to be cleaned up and I use a 50mm face mill to do that. Or maybe it's a big end mill, just depends on how you look at it. For the ends I used my old worn out long series 16mm end mill. I just got to get a new one. Yep, I really need a new long end mill. I'll use the face mill again to hog out the sides and remove the material not needed. That will also provide a space to draw some mounting holes. This aluminium swarf needs to be contained. The mill throws it everywhere. If the mill was located in the corner of the shed, it could just do what it does, but out in the middle of the shed I need to have some containment in place. The sheet metal cache tray works well at the back of the table, and I'll use a piece of cardboard to contain what's thrown to the front. I have seen vacuum systems with a brush on the bottom to sweep across the table used on big CNC profilers. That vacuum head was circular and mounted around the cutter. But that was on a big machine with a 40-foot long table, and it had two independent machining bridges to machine billets of aluminium that were 20 feet long. No opportunity to clear swarf on the run there, but it would be a bit out of place here. Or would it? A chamfer around the top and a final pass to clean it up, and I'll bore the airways. The holes are 11mm and the threads are 1/4 BSP. A hole right through the block will connect the cross holes to the outlets. That will provide adequate airflow to run all the items I need. Mounting holes are 6mm. A coat of paint and it's ready to assemble and mount. It has 2 air takeoffs and a ready to go regulator for a mist coolant system, and it fits well on the back of the machine. I decided to use a bigger isolation tap and mount the air input on the side. This made for easier routing of the air hoses. Well, that's it for now. I hope you liked this video and maybe got some ideas if you're looking to improve your own mill. As always, thanks for watching. Please give this video a like and subscribe to my channel if you haven't already. Be productive, be creative, but most importantly, be safe in your shed. I'll catch you next time.